This problem is concerned with predicting acid and base strength on the basis of a conjugate. So it's a little wordy, the explanation of this problem, but what you're asked to do is to rank 8 species from the most acidic, that is the one having the lowest pH, through to the least acidic, that is the one having the highest pH. And what is interesting about the list of 8 things that you're given is that they're actually 4 conjugate acid-base pairs. So if you write the list out in a table where you have acids on the left and bases on the right, this sort of becomes a little clearer. So we have H3O plus, and then we have its conjugate base, H2O. We have HNO2, and then we have its conjugate base, NO2 minus. We have HF and its conjugate base, F minus, and we have H3PO4 and its conjugate base, H2PO4 minus. So then when we look at the information that's given, we see that for each pair, we have the ranking for one member of the pair. So we have a 1 for the H3O plus, but nothing for the H2O. We have an 8 for the NO2 minus, but we have nothing for the HNO2. We have 3 for HF, but we have nothing for F minus. And then we have 6 for the H2PO4 minus, but we have nothing for its conjugate acid. So if we think about what we have, we've got 1, 2, 3, 4 acids. Remember, we want number 1 to be our strongest acid. So the first 4 numbers are going to be ranking the acids in order of decreasing acid strength. There we go. Now, our most basic solution will be number 8, and species 5, 6, 7, and 8 are going to be our bases, keeping in mind that this is our most basic one in order of increasing base strength. Now, we need to apply the rule about conjugates that says that the strongest acid will have the weakest conjugate base, and vice versa, the weakest acid will have the strongest conjugate base. So, number 1 is H3O plus. That is our strongest acid. That means its conjugate will be our weakest base. So that one must be number 5. Number 8 is our strongest base. So that means that its conjugate must be, let's make it a different shape, the weakest acid. So that one has got to be number 4. Starts getting a little bit kind of tricky from here on in, because you have to kind of make sure you don't get confused. HF is our third strongest strongest acid, or you can say that it is the second weakest. So therefore that means that it must be the second strongest. So that would put it in at number 7. And then we've only got 1 left, and what we see is that we have H2PO4, and that is our second weakest base. So therefore it must be our second strongest acid. Its conjugate must be our second strongest acid. So it's a little bit confusing, but that's how it works. You just have to kind of take your time. Second strongest acid, second weakest base. Third strongest acid, third weakest base, and so forth, right? So you're kind of counting backwards towards the middle. Okay, hope that is helpful.